Hello students, welcome to chapter 12, linear programming. Students, in this linear programming, we derive for subject to related some solutions for related your subject wise maximum value and minimum values. So in this chapter, first we start example 1, find the maximized value to z is equal to 4x plus y to subject given that x plus y less than 50, 3x plus y less than 90 and another two are derivation to x greater than 0, y greater than 0. Very easy. First I derive equation of line. So related that first, I will go to a line first, L1, x plus y is equal to 50 and make it table in the simple way x and y. If you x0, y50 or y0 then x50. And you first checking your shading towards origin or not towards origin. So I will check first x50 to related 0 0 less than 50. Surely it is true. 0 less than or equal to 50 means your graph going towards the origin. Now second line, is this related? Yes, that one. Line L2, 3x plus y is equal to 90 and go to same table, x0, y90. But if you y0, 90 by 3, yes, 30. And that also checking I towards origin or not, 0 0 sides. So 3x plus y less than 90. So it should be 0 plus 0 less than 90. Surely that's also true. Now students, here I will show the graph in the way of simple x-axis and y-axis. So that's your x-axis, y-axis related graph. It's very easy and very simple. X-axis to 50 and 30. So I will take 10, 20, 30, 40, 50. On x-axis maximum 50, but y-axis up to 90. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10, 20, 30, 40, 50, 60, 70, 80 and 90. Generally students graph draw on the graph page, but here I will draw without graph page. Very easy. 0 to 50, first one. 50 to 0, second one. And plot the table, simple graph. L1. Your line is x plus y is equal to 50, but check your graph going towards the origin. It means this side, here your origin. This side is your graph, just moving ahead. Now secondly, 0 to 90 and 30 to 0. That's a second equations graph. Very easy. They are common intersection points. The line L2 is that 3x plus y is equal to 90. But students, check this graph shaded portion towards the origin again. So this also shaded to towards origin. It means this sides, this line is towards the origin, this sides, this sides, this sides. So which is the common region? Yes, that's the common region. So you're very easy. Just apply your O, that is A point, that's the P point, and that is a B point. Now you can derive this P point by the elimination method. Yes, L1 intersection L2 is that P, and L1 I have x plus y, L2 3x plus y, and derive to simple elimination method. This cancel, minus 2x minus 40, x become 20 and y become same students, same value, just derive elimination wise. So x20, put it here x20, 50 minus 20, 30. So this point is 20, 30. Now I will plot my final solutions to related your graph. Yes, very easy. Last table, do you find out? Yes, z is equal to 4x plus y in maximum, your target. And here points related to your feasible region. Yes, point of feasible area, feasible region. and that potato points first P 2030, second A 30, B 050, and lastly students O 00. And simple, apply these solutions. So here 0 definitely you have to 0, that applies 0, x 0 y 50, here 4 is a 12, 120, and lastly 20 and 30, it is 4 into 80 plus 30, 110, and your target achieve maximum. That's your maximum students. So at the end of this sum I going that at a point 30 maximum value, yes, z values is what, 120 degree. And here students, you are easily first example done here. Now students, we are going ahead, example number 2. Same questions ahead, and find out that in the linear equations, example 2, for the z given 200x plus 500y, z is a 200x 500y, and find the value for its minimum. Yes, find its minimum value, and subject to constraints given, the simple 3 equations, and that equations I will solve and converting into table wise graph. So in the equations wise, the 3 equations given, first of all x plus 2y greater than 10 or equal to, secondly 3x plus 4y less than 24, x greater than or equal to 0, and y greater than or equal to 0. Very easy students. So I just first of all here taking line L1 and x plus 2y 10 conversions in the table. So only just 2 point taking, alternately x0, then y become 10 by 2, 5. But if you y0 then 10. And you're checking to originality, x plus 2y greater than 10. So it should be 0 plus 0 greater than 10. Surely 0 is not greater than 10. It is a false statement. Is your graph not to origin sides? Yes. Now second to here, line L2, I will take that 3x plus 4y is equal to 24, and go to simple again table values, x0 y0, and systematically apply to your first x0, then definitely you will derive y. X0 then it is 0, 24 by 4 it is 6, but if you y0 then 24 by 3 8, and here checking 0 towards to 3x plus 4y less than 24, so 0 plus 0 less than 24. Surely 0 less than or equal to 24 is true, means my graph towards the origin. And now here I will start my graph to y-axis and the x-axis sides. My x value is a 10, maximum 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and y-axis only 6 have to maximum. 1, 2, 3, 4, 5 and 6. According to table, you will just write down the numbers on the axis and y-axis. Now 0, 5, 10, 0. Both plot and go to line L1 shading x plus 2y is equal to 10. But students, check, this is your origin sides? No, it is not origin towards. So this answers to opposite to origin sides. This side my graph going. First of all. Now second, it is towards the origin, but 0, 6. And second, 8, 0. This 8, 0. These are the lines. This is second line L2. And both intersection common has just point P, but that is your towards the origin. It was downwards, this side your graph, this sides. It means your common region is this. That's my finally common intersection points, and that's I will show that 0, 5, B is 0, 6, and P I will go to elimination. Yes, L1 intersection L2, it should be P, and these two are I eliminate values. Just here multiply by 2x 4y 20, 3x 4y 24, and that's become cancel. That is your minus x minus 4. X is exactly 4, and students y become, just apply x is equal to 4 here. 4, 10 minus 4, 6, 6 by 2, it is 3. So it is 4 comma 3. That's become your P points. Now I will go to finally solutions for in this numericals. It's the find out the point wise. Yes, points on feasible region, either points of the feasible area. These are the points. Only P 4 comma 3. Yes. Second A 0, 5, and thirdly B 0, 6. And my Z point is find out that 200x plus 500y, and systematically apply their values. So 4 2s are 800 plus 5 3s are 1500. It will be 2300. Next is 0, 5 5s are 25. I want to which value? Yes, subject to minimum value. And next 0, 6 5s are 30,000. So that's your minimum value. And that is your answer, students. So last answer at P4 comma 3 Z 2300 is minimum value. If you are asking maximum, then 3000s. Very easy. Now continue I going example number 3rd. Yes, 3rd also very easy. Find out your Z given and in the subject to your values defined to as well as according to your textbook. So in the 3rd one, find out the minimum and maximum both. Yes, find out minimum and maximum of Z is equal to 3x plus 9y, and subject given x plus 3y less than 60, x plus y greater than 10, x less than or equal to y, and x greater than 0, y greater than or equal to 0. Yes, students, this 3rd example is an IMP example for board related. Because of that, only x less than or equal to y related. This is an IMP questions. And I will show that very easily solution here, students. So that I take first line L1 related and L2. And then after 3rd also L3. These are big solutions and big numerical also, students. So these are L1 taking line x plus 3y is equal to 60 and make to simple x and y, x 0, y 60 by 3, 20, but y 0, x is 60, and apply to checking also 0 0 is x plus 3y less than 60. So 0 plus 0 less than 60, and sure 0 less than 60, is it true? Means you are shading towards the origin sides. Now I will go to same second line to that one. So line L2 x plus y is equal to 10, and same going to simple your table x 0 y 10, but y 0 x 10, and here also I will check to 0 0 sides. So very easy, x plus y greater than or equal to 10. So 0 plus 0 greater than or equal to 10, but 0 never more than 10, it is a false. That's why your graph not towards the origin. Yes, and 3rd is a mean line L3 is that x is equal to y. It's very easy. If you're taking x 0, y 0, x 10, y 10, 20, 20, and here I will check to one point in another but not checking here 0 0 because this line itself passing through origin. Now I will plot my simple graph. This graph is very easy and simple. Maximum 60. I will check here 10, 20, 30, 40, 50, 60 and y-axis also just to 20, 10, 20, 30 and just apply this first line 0 to 20, 60 to 0, this line L1. Shading you know, x plus 3y, 60. Which side shading? True sides. Means towards the origin. This side is your shading. Full line. Now second, 0 to 10 and 10 to 0. This one. And this shading is also given that false sides, not origin sides. Opposite origin side, that sides. This shading. Now last, 0 0 is here, 10 10 is here, 20 20 is here, and this I connected the line. This is your L2 line, that is a L1 and that is a L3 line. But this line have two half plane, one of the upper half plane, one of the lower half plane. So any one half plane you will take 1 point. I just taking here 10, 30 P point. Any points but not nearest the line L3. This side 10, 30 checking and apply that 10. Yes, which is true. It means this graph to this sides all are. It means you this that left side, this upper side, this a left side means your shading is this. That's your final solutions. And I will take now points here A, B, that is Q, that is R. A is very easy, 0 10. B is also very easy, 0 20. But R and Q I will find out by the simple our eliminations. So students, first of all Q define L1 and L3. Yes, L1 intersection L3 at the point Q. So L1 and L3, L1 is this and L3 is this. X is equal to y. You put down here x plus 3x, 4x, x become 15, y become 15. Means this point is ready, 15, 15. Now I will go to R, L2 and L3. Yes, here go take 2. Also L2 intersection L3 at the point R. L2 is your lines given that x plus y 10 and x3, x is equal to y. So x plus x 10, x become 5, y also 5. The point is ready, 5, 5. Now I will go to final my answers. Yes, that is your final table to you will show in exam necessarily in the solution wise. Here points on the feasible area, either feasible region, and z become 3x plus 9y, but both asking maximum and minimum. So you points are apply systematically. First I go to A points, 0 10, B 0 20, now Q and last R 5 5, and attach the values. X 0 here 19, here 0, 9 2 is 18, next 15 3 is 45 and 15 9 is 135, it is 180. Yes, 13 14 15 16 17 18. Yes, and 5 3 is 15 and 9 5 is 45, 60. So you will show that these two are your maximum value and minimum I have to 60. Yes, that is your minimum value. So at the end of this sum, at B 0 20 and Q 15 15, Z is 180 maximum value. This is your first answer. And second answer, at minimum R5 comma 5 Z become 60 is minimum, and that should be simple answer. Now students, example third done here. Fourth is a cancel according to syllabus, so I will go through now fifth one. Yes, fifth is also IMP for exam oriented. Fifth is a different questions. In the solutions wise, they have no common region decided, that type solutions. Then you never find out the table, only just solutions say not exist. Now I continue example fifth one. In the subject 2, Z given 3x plus 2y, and find out its minimum value, not maximum, only minimum to Z, 3x plus 2y, and the subject given that x plus y greater than or equal to 8, 3x plus 5y less than or equal to 15, x greater than 0 and y greater than 0. Very easy. Just I will shape first of all here line L1, x plus y, and go to table. X 0, definitely y is 8, but y 0 then x is 8. Now you verify to your 0 0, put down there. Answer is 0 greater than or equal to 8. It is not true, it is the false. So your graph not towards the origin. Now second line L2, 3x plus 5y is equal to 15, and that should be table wise x and y. X 0, y is a 15 by 5, it is 3, but if you y 0 then 15 by 3, 5. So you are also checking 0 0, 3x plus 5y less than 15. So 0 plus 0 less than 15, it means 0 less than 15 is true. Your graph towards the origin. Now finally I will show my graph to x-axis and here origin to O. Now while you is given that 8 and 5 maximum, 1 2 3 4 5 6 7 and 8, and y-axis have maximum only 5, that I mean 8 also, 1 2 3 4 5 6 7 8. Now values 0 8 8 0, both of the match, and that's your line L1. But checking the syllabus wise that given false according to 0 0, surely not towards the origin. This side is your shading, opposite to origin sides. That side. But second graph here 0 3 and 5 0, these are the shaded, and this is your true sides, means towards the origin. This side your graph. Finally you will check they have no common region between that first and second figure. So that's why I write down here, there is no common area of region. Therefore this value Z have no minimum value, no maximum value. Therefore Z is equal to 3x plus 2y have no minimum values. And here students, our example 5 is done, and after that example 5 students, I will stop this video and further explanations to our exercise 12.1 in the next parts. Bye bye.